All right, here are solutions to quiz 3 from Math 60. The first problem, first part of the first problem, gives us a fraction and asks us to convert it into a decimal. I don't know if there's a couple different ways to do this. The way I've been teaching you to do this, without a calculator, it's kind of long division. 11 goes into 13 one time. 13 minus 11 is 2. It'd be nice to just say, so it's 1 with the remainder of 2. Unfortunately, we can't when we're trying to convert it into a decimal. What we got to do is kind of add a 0 here. If you bring down that 0, we got 11 goes into 20. See, that happens one time. 1 times 11 is 11. Subtracting out of 9. We still don't have a remainder of 0, so we repeat. Put another 0 here. Bring it down. 11 goes into 90 8 times. 8 times 11 is 88. Subtracting it at 2. Still not a remainder of 0. So what you have to do is bring down another 0. However, if you brought down another 0, you'd have 20 here. Kind of the same thing we had up here at this step. We'd say it goes in one time, and then we'd get 11, and subtracting it 9, and then 8, and 1, and 8, and 1, and 8, and we just keep repeating forever. So kind of what ends up happening is you get 1, 8, 1, 8, 1, 8, and so on. In other words, our answer is 1.18 with the 1, 8 repeating. And the way you signify repeating is put a bar over the digits that repeat. So the first one is 1.18 repeating. The next one, 9 eighths. Same sort of idea. We'll take the 8 and divide it into 9. It's not enough room, so I'm going to try that again, and maybe I'll switch colors so they don't run into each other. Same idea, take the 8, divide it into 9, it goes in one time. Subtract, you got a 1 here. We want a remainder of 0, so we have to put in this decimal place and bring down the 0. 8 goes into 10 twice. No, that's not true. 8 goes in, I shouldn't watch football. 8 goes into 8 one times. 8 times 1 is just 8. 10 minus 8 is 2. Still not a remainder of 0. So we add another 0 that we bring down. 8 goes into 20 twice. 8 times 2 is 16. 20 minus 16 is 4. Still not a remainder of 0, so we bring down another 0. 8 goes into 40 5 times. It's good news because 8 times 5 is 40, and we're now left with the remainder of 0. So what we get down here is 1.125 as our final answer. Nothing repeating, this is the end of the decimal place. All right, using your answers part A and B, determine whether each statement below is true or false. All right, so 13, okay, let me rewrite this. This is the absolute value of negative 13 elevenths. We figured out that was negative 1.18 repeating. So we want to know, is that absolute value greater than the absolute value? Well, let's do this another way. Negative 13 elevenths absolute value is the same as the absolute value of negative 1.18 repeating. That's what we figured out above. And the absolute value of negative 1.18 repeating is just 1.18 repeating. And then the absolute value of 9 eighths is the same as the absolute value of 1.125, which is just equal to 1.125. And then we compare these two. 1.125 is less than 1.1818, right? 8 is bigger than 2. So this one up here is bigger, which means this right here is bigger, which means this right here is bigger. So this is true. Now it's saying, all right, is negative 13 elevenths less than negative 9 eighths? Well, negative 13 elevenths is equal to negative 1.18, and negative 9 eighths is equal to negative 1.125. So if I were going to make a number line, and I had 0 here, and negative 1 here, and negative 2 here. Let's see, this one, this negative 1.18 repeating, is further to the left than this one. So this guy, I don't know, maybe he's right there-ish, whereas this guy is just slightly to the right of it. That's a horrible picture. So maybe not drawn to scale, but the point is this guy is further left of this guy. So what that means is this guy is less than this guy. It means that this statement right here is true. All right. Moving on. Simplify the following algebraic expressions. So in this first problem, what we have to do is distribute. We actually have to distribute twice. To get rid of these parentheses, we'd have to take this 3 and distribute it through. That would give us 12x minus 15. To get rid of these parentheses, we take the negative 2 and distribute it through. Be careful, it's negative 2, not just 2. Negative 2 times 4x is negative 8x. Negative 2 times negative 3 is positive 6. And now that we've gotten rid of all the parentheses, we can combine like terms. 12x minus 8x. See, 12 of these things minus 8 of them, I'm left with 4 of them. Negative 15 plus 6 gives me negative 9. And that's as far as I can go. You can't combine the 4x and the 9 because they're not like terms. So this right here would be my final answer. Fractions. All right, we can do this. A couple options on how you do this. You could look at this and try to get rid of the parentheses immediately. However, there's actually an easier way to do this. It's a little bit easier if you combine like terms inside the parentheses first. So what I'm saying is 7 minus 1 is just 6. And then 7x minus 4x is 3x. And so if you take that 2/3 and distribute it through, what you have to figure out is what is 2/3 times 6 plus 2/3 times 3x. What I like, how I think about this is when you're multiplying a fraction times a whole number, make it a fraction times a fraction. Write this as a fraction. The way you write 6 as a fraction is it's 6 over 1. Similarly, 3 as a fraction is 3 over 1. So 3x is 3 over 1x. And you can kind of think about this 3 and the 3 that makes up this 6 is canceling out. And so what I'm left with is just a 2 up here. In other words, I get 2/3 times 6 is equal to 4. And if I cancel out this 3 and this 3, I'm left with just a 2. I get 4 plus 2x. And again, we can't combine those because they're not like terms, so that's our final answer, 4 plus 2x. Maybe it's worth writing. You could also say 2x plus 4 makes no difference. Similarly, up here you could say negative 9 plus 4x. It's the commutative property of addition. Doesn't matter which way you write it in. Either way is totally fine. So I guess that's good. We'll call that the end of this quiz.